Okay, welcome to this lesson on writing numbers in scientific notation. This is part of our first unit on exponents in scientific notation in pre-algebra. So a number in scientific notation is a number that can be written in the form a times 10 to the z. Okay, a is a number between 1 and 10, so it's bigger than or equal to 1, but also smaller than 10. And that's because we don't want anything that can be divided by 10 because all the power of the number is in the 10 at the end. And the z, or the exponent, is going to be an integer. It can be negative, it can be positive, it can be zero. So scientific notation is going to be the one exception to writing numbers with exponents where you can have a negative exponent in the final answer. So the size of the number is all held in the power of 10. That's going to help us write like big and small numbers. So the number 3 times 10 to the third here is the same as saying 3 times and 10 to the third is 1,000, which is going to be 3,000. So we can see that a positive exponent, like here, this positive power of 3, makes the number larger, bigger, because you're multiplying it by a positive power of 10, which is just a 1 with a bunch of zeros after it. However, the number 2.75 times 10 to the negative second, well, 10 to the negative second is 1 over 10 to the second, which is 1 over 100. And in decimal form, that is 0.01. So we are multiplying it by a small number of 0.01, or taking 1/100th of the number. So this is 0.0275, which means that a negative exponent makes the number smaller because you're taking a fraction of it. Why do we write numbers like this? Well, scientific notation is used in scientific fields as a shorthand for writing very large or very small numbers. So very large, like we're talking like the size of a galaxy or a solar system, or the number of cells in the human body. Those are very large numbers. Very small numbers would be like the size of a cell or the size of an atom, that kind of thing. Very, very small amounts with a lot of decimal places that are cumbersome to write down. So let's learn how to take a scientific notation number and change it to standard form. Okay, scientific notation standard form is just going to be like regular numbers. So if the power is positive, you are going to move the decimal to the right, the number of spaces that the power says. If it's negative, we're going to move the decimal to the left, the number of places that the power says. We are going to rewrite our final number because we're going to mess up the number while we're writing it, so we want to write it neatly. And if the number is smaller than 1, we need to put a leading 0. We're not going to start with a decimal. We'll be like 0 point whatever it is. So let's look at this first example here, rewriting a number in scientific notation to change it to standard form. So I have the number 5.2. But since the power is a 4, that means we're going to move the decimal 1, 2, 3, 4 spaces to the right to its new location. So that's gone. Okay, we fill in all the loops with zeros. And so we have 5, 2. We're rewriting the number now, so 52,000. So we can see that positive exponent of 4 made the number larger. If we have a negative exponent, like here, 2.3 times 10 to the negative fifth, that means we're going to move the number, or the decimal, left 5 spaces. 1, 2, 3, 4, 5. 0, 0, 0, 0. So the old decimal is gone. I have 0.000023. And since the number is smaller than 1, we need a leading 0 before the decimal point. So positive exponent means to move it to the right. Negative exponent means to move it to the left. And I'm going to say rewrite the final number with our zeros filled in for the number of loops that you didn't have any digits in. All right, let's talk about now changing a number from standard form to scientific notation. All right, so our directions say first, note where the decimal is in the number. If it is a whole number, put the decimal to the right. So I'm going to use this example down here. So the decimal is far at the end. Second, write 10 to the 0 times 10 to the 0 at the end of the number. Yes, we're going to start with it being a power of 0 because that means that I have the number of 980 million really times 1. 10 to the 0 is 1. We aren't changing the value of the number. We aren't changing what it's worth. We're just writing it in a different form. Just like writing a word in a different language, it doesn't change what it means. Next, move the decimal point of the number so that the number is between 1 and 10. Note whether you move left with a negative or right with a positive. So I need this number to be between 1 and 10 because in our scientific notation definition, we said this number here, the A number, had to be between 1 and 10. So to make that happen, I can't have the decimal here. That's 98. That's too big. I can't have it here. It's 0.98. It's too small. It's got to be between 1 and 10. So the decimal place is going to move from where it was to be right here. Now we're going to note how many places we moved it. Well, we moved it to the left. 1, 2, 3, 4, 5, 6, 7, 8. We went left 8 spaces. It's very important that you write that below. And if you move left, make it negative. If you move it right, make it positive. Because after you move the decimal and you note how many spaces, that's going to be the power that goes up here, except for you do the opposite. Okay, so if we moved left and we have a negative 8 down here, we add that digit. So we put plus 8 here. Okay, if we move right and we had a plus, we would do minus up here. So these are always going to be the opposite, this one and this one. And I'm going to want to see those numbers written down. Now we can rewrite our final answer. So now it's 9.8. I don't need all those zeros because they're to the right, times 10 to the 0 plus 8 is 8. All right, let's try a couple more. If you want to try this on your own, you can pause the video, try it, and then come back and check your answer, which would be really good. All right, so the next one says, the approximate distance from the Earth to the Sun is 93 million miles. All right, my decimal's at the end because there's no decimal in the number, and I write times 10 to the 0. Now let's move our decimal so that the number will be between 1 and 10. So we're going left, 1, 2, 3, 4, 5, 6, 7 spaces. Left 7, so I put a plus 7. And rewrite my final answer, 9.3 times 10 to the 0 plus 7 is 7. So there we go, scientific notation on that one. Now let's try this with a number that's smaller than 1 to see how it works when you have the opposite powers. So the width of a human skin cell is about 0.00003 meters. All right, so we don't need to put a decimal at the end here because this number already has a decimal right there. But I can write my times 10 to the 0. Now let's move some decimal places. This one, to make this number be between 1 and 10, the decimal would have to be here and make it 3. 1, 2, 3, 4, 5 spaces to the right. So I'm going to write plus 5, which means up here I'm going to do the opposite and write minus 5. Now I can rewrite my final number, 3 or 3.0 if you like, times 10 to the negative 5. You can always check your work because if I go back and I move this 7 spaces to the right to change the scientific notation to standard, I'll get back that original number. If I take this one and I move the decimal 5 spaces to the left, I will get back my original number. So it's a nice way to check your work. Okay, next, we're going to talk about correcting a number in scientific notation. We're going to use the same process we did just now to change a number into scientific notation. However, we won't need to write a times 10 to the 0 because of the fact it's already got a times 10 to the something. All right, so I have 20, I'm going to write my work here, 23 times 10 to the negative fifth. The decimal in 23, if it's not there, is at the end of the number. All right, now I'm going to move that. I'm going to make this number be between 1 and 10. So I have to move it to the left one space to fix it, which means I do the opposite and add one space there. So it's very similar to writing a number in scientific notation. You just move the decimal to where it has to be between 1 and 10. So my new number is 2.3 times 10 to the, and when I add my exponents, using my laws of exponents, I get negative 4. All right, if you want to try the next one on your own, you can pause the video and then come back and check it. So 0.31, 0.031 times 10 to the third. All right, so if I want to make this initial number be between 1 and 10, the decimal would have to go here, which means I am moving it 2 places to the right. So I'm going to subtract 2 here. I get 3.1 times 10 to the first power. It is possible to have a decimal in scientific notation with a 0 power if you don't need to move it at all. All right, last problem, and then we are all done with writing numbers in scientific notation. We're going to talk about ordering numbers in scientific notation. The first thing you do is order the powers of 10, because as we said at the very beginning of the lesson, the size of the number is held in the power of 10. So if we're going to go smallest to largest, we're going to start with our smallest power of 10, which is negative 8. So my first number is 5 times 10 to the negative 8. Done. Okay. Next biggest number, well, I have 2 of these that have a power of 3. So I have to look at which one now, compare the coefficients if 2 values have the same power of 10. So 1.29 is the next biggest one. So that's a power of 10. Done with that one. Then 7.19 times 10 to the third, because those both have the same power of 10. And then last but not least, 2 times 10 to the 6 would be the fourth number. If one of the numbers is not in scientific notation, put it in scientific notation before you start ordering your numbers. So that is the end of this lesson on writing numbers in scientific notation. Our next lesson will be multiplying numbers in scientific notation.